Perfect. We are going to add other variants because with this alone, we are not going to understand all the electronics. We are going to understand something that we call. I am going to write here so that it can be seen clearly, alternating current. And direct current. It will be essential that we understand the difference between alternating and direct current because that is what the inverter system is about. Now I will explain a little more. We are going to delete this then. And we will explain what alternating current and direct current are, fundamental details to understand. Any inverter circuit. Well, precisely, inverter or investor refers to this process. Actually, any electronic board that they are dealing with, these electronic boards, what they do is convert alternating current, AC, into direct current, DC, an inverter circuit to be able to do run an engine. Instead of directly injecting alternating current as we did in the conventional system, what it will do is convert it into direct current and then convert it back to alternating current. That is, something is converted and that conversion is inverted again, hence its name inverter system. The motor will work with alternating current in both systems, in the conventional and in the inverter. The difference will be that the conventional motor will work with the alternating current provided by the electric company, but an inverter system will work with an alternating current that will be generated or created electronically and modified. That is the big difference between a conventional system and an inverter system. When this conversion into investment occurs, we call it an inverter system. Well, now the question is this. What is alternating current and what is direct current? If we said that it was the flow of electricity electrons, this difference will be in how the electrons circulate in a circuit. What do we mean? Now let's talk about direct current. Simply, we can draw it this way. A tank with water pressure, and the water circulating in only one direction. This would be direct current. Now, alternating current is a bit more complex, and that's what we're going to talk about now. Let's first look at alternating current. We analyze it in depth and see other parameters to take into account, and then we are going to talk about direct current again, which is the simplest. Let's continue comparing it with water to understand it. Imagine a water tank, a circuit, and another water tank, and there we stay. Now, imagine a water pressure a little larger on one side and a little smaller on the other side. When I pour water into this pipe, what is going to start to happen is that the electrons are going to circulate to that side to produce an equalization of the pressures. Then, the electrons are going to push there. And what if I had a system that constantly causes the water pressure to never be the same, but instead constantly stays with one tank fuller than the other? Well, if you had a system that could do this, the water would flow back and forth constantly. And this is alternating current. So that you understand, this is the electricity that you have in the outlets at home. This would represent the neutral, and this would represent the line. When you plug in a device, one side has more electrons than the other, then there is a circulation of electrons in one direction. Now, the electric company with its motors constantly is just doing that these tanks never equal. It constantly has one more full, the other more full, the other more full, the other more full. So, the electrons are going to go back and forth constantly. It is true, it is better to use direct current for everything, but this alternating current can be transported long distances with thinner conductors or cables without losing pressure. For this reason, alternating current is used to transfer electricity. If we wanted to move electrons in only one direction, we would need very thick cables, and even then we would still lose pressure. That is why alternating current is used. Our electronic boards, all the electronic board, including cell phone chargers, transform it into direct current in order to use it. Very good. Now there are more parameters to take into account. On the one hand, we have the tension, measured in voltage. We also have the amperage, which depends on the driver and the pressure. In addition, we have to consider the resistance to the passage of electrons when this circuit is powered. But there is a more important data to take into account. How many times do the electrons go to one side and to the other? This data is the frequency. This frequency is what we measure with hertz. In your home electricity, these hertz are 50 or 60, depending on the country where you are. What does this mean? That the electrons are going to go to one side and to the other 50 or 60 times per second. And these times per second are hertz. Now that we understand what alternating current is, we are going to draw it in another way, in a more electronic way, to understand it better. We are going to do a cleaning of our electronic blackboard. And we will draw the electrical conductors. Here we would have the neutral and the line, and here we plug in a circuit in this case. The electrons start to circulate to one side. But in the next moment in time, they would already start to circulate to the other side. They constantly do this back and forth, and they do it 50 or 60 times per second. This represents alternating current. A symbol that is also used to represent alternating current is this wave. Let's see if we improve a bit. It is used to symbolize alternating current. Because the electrons enter from one side and the other. Now, if we want to draw the direct current, as I told you, it is much easier. In this case, we have a negative pole and a positive pole. Where do the electrons come in? I always ask the same question in live classes. Many times many answer that it is positive, but no, electrons are the negative charge of an atom and enter through the negative pole. A clear example of direct current is a battery. A battery represents direct current, while the electricity we have in our homes represents alternating current. Direct current naturally has no frequency, so that its frequency is zero. What is it called? We can find it as DC, or we can also find it as CC, or with its symbol, like this. In this case, a question I want to answer, if you have it in your mind, is, why doesn't the negative wire electrocute me when I touch it? Let's remember that this negative wire is charged with electrons, and this one has a lack of electrons. My body and the Earth have the same amount of electrons. Then the neutral wire. What does it mean? If I touch the neutral wire and touch the wall, I won't be electrocuted because it is neutral. The difference in electrons, the amount of voltage between the wall, the floor, my body, and this neutral wire, is the same, therefore no electrons will circulate inside me. On the other hand, if in this case the line, I am electrocuted, because there are holes here, that is, there are missing electrons. When I touch the wall or the floor and I touch the line cable, the electrons circulate from the wall towards me and from me towards the line cable, and that is where this circulation of electrons burns me inside and electrocutes me. One detail to keep in mind is that if I am not touching the wall or the floor, if I am insulated with rubber or another insulating material, I can touch the line wire or the neutral wire and neither of them will hurt me. Absolutely nothing, because there will be no circulation of electrons. Now if I touch both at the same time, yes, of course I get electrocuted. This explanation is so that you know why the wire charged with electrons does not electrocute me. Let's go ahead. We had said that in electronics we need to convert alternating current into direct current. Yes, every electronic board, to begin with, converts alternating current into direct current. Afterwards, the inverter converts the direct current back to alternating current, but that comes later. The first process. This conversion, how is it produced? What is it called? What elements produce it? That's what we're going to be talking about from now on. So that you know the name of this conversion, we call this process rectification. It is the process in which we change alternating current to direct current. We are going to explain how this is produced inside a platelet. Comparing it with water, you will understand it perfectly. Let's move on.